my name is Vivien Nagy from the University of Iceland, and the title of my presentation is Development of Production Method for a Bioactive chitosan Derivative. Chitosan is a biopolymer derived from chitin, which is quite abundant in nature. It can be found in arthropods, fungi, and crustaceans such as lobsters, crabs, and shrimp shells. Chitosan is produced by the deacetylation of chitin, resulting in a polymer of randomly distributed D-glucosamine and N-acetylglucosamine monomers. It possesses antimicrobial activity. It has antitumor, hemostatic, film-forming, fat-binding, as well as other properties. Chitosan is non-toxic, biodegradable, and a biocompatible material. Chitosan has very versatile applications such as in medicine, food agriculture, cosmetics, and nutraceutical fields. Primex is an Icelandic marine biotech company located in the north of Iceland, established in 1997. Primex is a global leader in producing high-quality chitosan from shrimp shell waste. Primex is manufacturing valuable chitosan products. These are KetoClear, which is used in food, medical, and cosmetic fields; KetoCare, which is a wound care line that stops bleeding and promotes rapid healing; Liposan, which is a weight loss supplement suitable for both humans and animals; and SeaClear, which is a water treatment for swimming pools and hot tubs. In 2012, Primex received the Icelandic Innovation Award. Primex produces the highest quality chitosan from marine sources and has several certifications, such as a certified natural product and a halal product, and more. However, the main producer of chitosan today is Asia. The quality of their product is not high because of pollution with heavy metals and other contaminants. Therefore, Primex has the advantage of high quality, but the shrimp shell waste is not going to increase in Iceland, so the amount of chitosan is limited. Also, the quality of the Asian chitosan has recently started to improve. Therefore, to stay ahead of Asia, it's not enough to have high-quality chitosan, but it is also important to develop innovative chitosan products and chitosan derivatives. One interesting and valuable chitosan derivative is the 3-methyl chitosan, or TMC. Unmodified chitosan has poor aqueous solubility. Therefore, the approach is to modify chitosan to improve water solubility. 3-methyl chitosan has improved water solubility, furthermore enhanced antimicrobial activity compared to unmodified chitosan. It is aimed to be used in drug delivery applications, and there are several published methods available on the synthesis of 3-methyl chitosan. However, they have some drawbacks, such as long reaction time, using excess reagents, and resulting in undesired products. Therefore, developing a better method is required. In the synthesis of 3-methyl chitosan, it is crucial to obtain a high degree of 3-methylation to improve the water solubility and the antibacterial activity compared to the native chitosan. There have been publications in our research group on the efficient synthesis of 3-methyl chitosan with high degree of 3-methylation. In one of these publications, up to 85% degree of 3-methylation was obtained, but the 3-methylation reaction had to be repeated 4 times in order to achieve this. Furthermore, it was not truly a one-pot synthesis. Significant excess of the reagent had to be used. The reaction time was very long, 8 days. And later it was also found that the method did not have good reproducibility. To overcome this, we can optimize the synthesis procedure. This can be done using the design of experiment approach, which is a systematic engineering method to optimize systems with multiple variables so that minimal experiments are required. It is used to investigate various processes, taking into account multiple input variables, which we call factors, and outcomes, which are called responses. The design of experiment identifies the factors that affect the responses, designs the experiments with minimized uncontrolled factors, and then uses statistical analysis to evaluate the results. In a full factorial design, the number of experiments can be calculated where L is the number of factor levels and K is the number of factors. With 2 factors at 2 levels, a square can be visualized, which consists of 4 experiments, while 3 factors on 2 levels, a cube can be visualized, and the design consists of 8 experiments. A software called Mode was used in this optimization. So the aim of the project was to develop an eco-friendly, safe, and cost-efficient production process for the synthesis of 3-methylchitosan, which is suitable for application in medical products, regenerative medicine, and cancer drug delivery. The goal was to obtain a highly 3-methylated chitosan through the design of experiment method. The first design was done using no software, therefore it consisted of 5 simple full factorial designs. In each design, 2 factors on 2 levels were explored, and the optimal experiment was used as the starting point of the subsequent design. In these designs, reaction parameters like molar ratios, solvent system, alkylating agent, reaction steps, temperature, and time were varied. Throughout these 5 simple designs, up to 53% degree of 3-methylation was achieved in only 1 step. It also helped to establish better reaction conditions, which will be further explored in the next designs. When these results are compared with the previously published method used in our research group, it is visible that much higher degree of 3-methylation was obtained in only 1 step with the new method, namely an 8-fold increase in 3-methylation. Next, a fractional factorial design was performed, which is a good screening method to identify the main effects of variables with minimal experiments. Since 4 factors were explored on 3 levels, a full factorial design would have consisted of too many experiments. In this fractional factorial design, the highest obtained degree of 3-methylation was 59%. While this was not a significant increase compared to the first design, this was a good screening step. The responses were the degree of 3-methylation and the yield, and it was established that the reaction time is insignificant for both responses, which means that it's unnecessary to run the reaction for 2 days. In case of the degree of 3-methylation, the equivalence of the alkylating reagent, the equivalence of the base, and the temperature were all found to be significant factors. The next design was a full factorial design exploring 2 factors, the base addition and the temperature, on 3 levels. The reproducibility was good, and all factors were found significant. The highest obtained degree of 3-methylation was 72% at 60 degrees with adding the base in 2 parts. This was a 12-fold increase in degree of 3-methylation compared to the initial method. And in the previous study, 85 degree 85% of trimethylation was achieved repeating the experiment 4 times, while here up to 72% was obtained only in 1 step. So to conclude, a new production method for the synthesis of trimethylchitosan was developed and optimized by the design of experiment approach. The degree of trimethylation has been significantly improved from 10% to 72% in 1 step. The method has excellent reproducibility and shortened reaction time with a quicker workup. The method results in a high-quality product with no contamination and no O-methylation. This work will be continued and further designs will be carried out to explore the use of different bases and different solvents as well. I would like to thank my supervisors, Professor Marmausson from the University of Iceland and Dr. Helen Uzon from Primex, and you for your attention, and I'm happy to answer questions. Thank you.